Minor types of CPTs.
This chart has previously been shown in Chapter 1, which covered the 4 major types of CPTs shown in red boxes. For this chapter, we will cover the next 6 types of CPTs known as the minor CPTs, marked in green boxes. Minor CPTs in this video series does not refer to the size of the CPT. It refers to market share in its application in urban areas. For example, a funnitel is a large system with a big cabin, but its market share when compared to an aerial cable car is small.
These are the 6 other and minor types of CPTs. They are not as common as the major ones. The major ones are the most likely types that can be installed in the Philippines. Anyhow, the minor types of CPTs will be covered in this chapter as they still have the possibility of being installed in the Philippines. These CPTs are plotted in the simplified chart. They are marked in green labels. These are bi-cable ACC, funnitel, pulsed gondola, funny4, inclined elevator, and drag lift. A bi-cable is a type of ART that uses 2 cables to support and propel a cabin between 2 stations. This is an example of a bi-cable ART located in Hong Kong.
In a bi-cable ART, one cable supports the weight of the cabin. The other cable pulls the cabin towards the destination station. There are very few bi-cable ARTs in the world, especially in the last 30 years, because of the significant improvements in the monocables and tri-cables. For example, current maximum speed of monocables is 25 kph compared to a small increase of 27 kph in bi-cables. The current maximum capacity of monocables is 12 passengers compared to a small increase of 17 passengers in bi-cables. Both have the same allowable wind speed condition. The tower-to-tower span of an installed bi-cable is 500 meters longer than a monocable, but this does not mean that at current technology, this distance cannot be closely achieved by a monocable. The current system capacity of monocables is 4,500 passengers per hour per direction. It is higher than 4,000 of the bi-cable. This is made possible by the closer spacing of cabins. If higher specs are required by a customer, a tri-cable can likely provide a better alternative. Each type of aerial cable car has its pros and cons. Each ART customer has its own requirements. The best way to determine which type is best suited for a particular area or need is through a feasibility study. The tower-to-tower distance capability of ART shown in the previous page is important in choosing a type of ART. Logically, the more cables to carry the cabins between towers, the farther the distances the towers can be placed apart. These 3 examples are actual installations of tower-to-tower distances to overcome a sea channel. The tower-to-tower distance of this monocable in South Korea is 1 kilometer. The tower-to-tower distance of this bi-cable in Hong Kong is 1.5 kilometers. The tower-to-tower distance of this tri-cable in Vietnam is 2 kilometers. These long distances cannot be achieved by other modes of transportation. All modes have to rely on bridges or tunnels below the seabed for the respective transport vehicles to pass. This capability of ART is one of its many big advantages. It is very expensive to put a foundation tower on a seabed. It also restricts the navigation of marine vessels.
This is an example of a funnitel in St. Anton, Austria. A funnitel is a type of CPT that uses 2 overhead hanger arms to transport people or cargo between 2 stations. The 2 arms are attached to the 2 cables that serve as support and propulsion cables at the same time.
To further appreciate the stability of a funnitel, we compare it with a monocable and tri-cable ART. The monocable has the lowest resistance against high winds since it has only 1 cable.
A tri-cable is more stable since it has 3 cables to provide balance. A funnitel has 2 cables only, but the cables are spaced about 3 meters apart and supported by a steel frame. A funny tail can still operate at wind speeds of 100 kph. Winter is the equivalent of rainy season here in the Philippines. It is generally more windy. If a place is really attractive for skiing and windier than normal, a funny tail can be installed.
70 kph, which a monocable ART can still operate, is already on the lower end of typhoon signal number 2 in the Philippines, while 100 kph, which a funny tail can still operate, is already on the higher end of typhoon signal number 2.
This is the arrangement of the continuous cable and bull wheels of a funny tail and how its cabins move. A pulsed gondola consists of closely spaced cabins that are clamped and fixed to a cable. It is propelled back and forth like an aerial tram. The two groups simultaneously travel in opposite directions. In some cases, pulsed gondolas can also be recirculating type like a monocable ART. This pulsed gondola is located in Santorini Island, Greece. It is one of the top tourist attractions in Greece. It has a magnificent view of steep coastal cliffs with an overlooking view of the ocean.
This slide shows the similarities of the pulsed gondola and the reversible tramway. In a pulsed gondola, there are 10 passengers or less in a cabin. The passengers are spread out in 6 cabins per direction. All seated passengers will have a best view of the surroundings. In an aerial tram, there are 25 to 230 passengers in a cabin. Those in the middle will have a lesser view of the surroundings as there is only one cabin per direction. If the slope of travel is consistent between two stations, the boarding and deboarding area can be arranged to be sloping too. This will minimize the amount of moving parts that will result in lesser operational cost. This will be the same for a funicular shown on the right. A pulsed gondola exists as of the present at the Tagaytay Highlands in Cavite. However, it is only available to members or to those who have properties inside this very exclusive residential and resort complex. This is an example of a funifor in Trento, Italy. A funifor is a type of cable car that has a set of support and haul ropes on both sides. The cabin is moved back and forth like an aerial tram. But this time, the two cabins can move independently of each other anytime. This is a close-up view of the hanger frame assembly of a funifor. It now has a horizontal frame. It has 2 support cables. It has a separate haul rope that is looped between the 2 stations. It also has a pneumatic suspension system to stabilize the cabin against vertical movement during strong winds. Let us put a funifor and an aerial tram side by side to understand its differences better. In a funifor, cabins travel independently of each other. A funifor has a higher daily ridership since both cabins can run anytime independently of each other. The cabins can sometimes be seen together at a station. If one cabin is out of order, the other cabin can still function to transport passengers, though at a reduced capacity. In contrast, an aerial tram is like one elevator. When this cabin is positioned here, the other cabin is on the other side, which cannot be seen in this photo. An aerial tram moves like the cabin and counterweight of an elevator. In a funifor, the cables of the 2 cabins are independent of each other. The cabins can travel in opposite directions. It can also travel together in the same direction. In an aerial tram, the cables of the 2 cabins are connected to each other. The cabins can only travel simultaneously in the opposite direction. They cannot travel in the same direction. This is a short animation of how one cabin per line of a funifor system works. This is an example of an inclined elevator in Austria. An inclined elevator is just like an elevator, except that it can travel in an inclined position. In some cases, an inclined elevator is cheaper than a vertical elevator to transport passengers between desired origin and destination. For example, if an elevator is to be built under this topographic condition, a vertical elevator is needed here and a passenger tube here. No matter how steep the slope and the number of times it changes the inclination during travel, the cabin will always be level. There is a leveling mechanism here to make the cabin always level. Like vertical elevators, inclined elevators are used to supplement stations in mass transportation systems. This photo is in the green line of the La Paz ART, in which you can see a green cabin flying by. It is used to transport PWD passengers and senior citizens from street level towards the station. Other passengers take the stairs. A drag lift is a device placed between the legs that propels an individual skier up a mountain slope. The following are notable photos of minor CPTs. These are the only 2 bi-cable aerial cable cars in an urban area since the first urban ART was installed in 2004. This is a photo of a ski resort in Ischla, Austria. Some ski slopes have a combination of aerial trams, aerial cable cars, and funitels. In this photo, it is a combination of funitel and monocable ART. If the wind speeds reaches 70 kph, the monocable ART will be closed. The ski resort can still remain operational since the funitel can operate at 100 kph. This is another example of a funitel in Mount Fuji, Japan. Both volcanoes, Mount Fuji and Mayon, have similar looks. Instead of snow, Mayon is capped with black lava flow as it is still a very active volcano. Let us hope that Filipinos and tourists will enjoy this most perfectly shaped volcano in the world through an ART soon in the future. This is a photo of a pulsed gondola in Namur, Belgium that was installed only in 2021. This is a photo of a Funifor in Stanzerhorn, Switzerland. It can accommodate 60 passengers, with passengers choosing where they want to ride, namely on the lower deck or the upper deck. This is a slide showing photos of the upper and lower stations. The stations are walled in glass. This will allow the bull wheels and machineries to be seen by the public as an added tourist attraction. These are more photos of the same ART. With these 2 amazing views, Filipinos can now think of where they can apply their own touristic ART. This could be on top of a mountain with a view of its surroundings, of a lake, forest, ocean, city, or a combination thereof. This diagram shows more details on the internal mechanisms of this Funifor. These are notable videos of minor CPTs. This is a bi-cable type of ART. This is a funitel type of ART. Funitel cabin is seen entering a station. This is a pulsed gondola type of ART. Pulsed gondola is seen traveling in opposite directions somewhere at midpoint. This is a Funifor type of ART. Funifor is seen here traveling independently, while this cabin is waiting for more passengers before it leaves. Funifor traveling together in the same direction. There is an unlimited source of information about CPTs and ARTs on the internet. These can be obtained through Google search and YouTube. With so much information, it may take a lot of effort to filter the sources that can provide the needed and most useful information. To help those who want to learn more about this technology, we are recommending the following good sources of information. The most comprehensive website on cable-propelled transit is this website called Remonte Mécanique. It contains details on most of the major installations of CPTs in the world. The next useful websites in the amount of content and quality of information are these 4 websites. All these 5 recommended websites provide information on the basics and latest information on CPT technology. They also include links to videos and other sources of information. Some CPT manufacturers have their own magazines and brochures. Doppelmayr, the largest manufacturer of CPT systems, has an excellent magazine providing the latest news and information on CPTs. CPT manufacturers continually feed its customers and the general public on their latest and future technologies. This is an excellent book of CPT technology that can be purchased online over the internet. There are numerous explanations and illustrations here on how different kinds of CPTs work.